I'm going to finish off the window to viewport material a little bit with a short programming session here. Just make a recording of this as well. So I'm going to just look into the program that we had in the lab class yesterday, where we're drawing some circles and some rectangles. And I'm going to see if we can, to begin with, manipulate the viewport a little bit, manipulate the world window that we're drawing into, and finally to see if we can do something like a split screen and have like 2 points of view on the same program and see how we need to manage our OpenGL code in order for that to work. So to begin with, we have this circle graphic and rectangle graphic, and we'll just say that these are kind of just black box classes. They know how to draw rectangles for us, they know how to draw circles. What we're interested in here is our main display function. So this function is run every single frame again and again and again. And what we do is we start by clearing the buffer. And then I'm setting some things here. I'm setting a color, and I'm setting some matrix translation and matrix scale. And we'll learn more about these transformations later on. And then I draw a square. And then I do the same thing. I set a new color, I set a new translation and a new scale. So I'm setting up the OpenGL pipeline for each object that I'm drawing. And so what we get is we get these different objects. So we have these outline circles and outline squares and solid ones in different colors. So this isn't too complicated. And all of this are just random numbers I threw in there. So nothing super cool here. But what we want to do now is to see kind of another form of scaling our picture, which is not through what we've been doing now, which is putting kind of a scale into our shader for each object that we're sending through it, but instead to kind of set the overall scale of our environment or the overall scale of our world that we're drawing into. So one of the things we have here is the viewport, which is setting the area on the screen. Sorry, gl.gl viewport. So okay, so I set this up as a viewport with left, right, bottom, top last time, but here, sorry about that. Here we're setting up X and Y, which is basically the bottom left corner. So it's the X and Y coordinates for the bottom left corner of the viewport that we're going to draw. And we have width and height. Okay, so the window that we're already drawing into, we can go into our desktop project here, desktop launcher, and see, okay, I'm setting up a window that's 1024, 768. So since I've never called GL viewport, I can just assume that the default is exactly the full viewport that I'm drawing into. So the default that we have now would be 0, 0, which is the bottom left corner of the entire screen that we're drawing into, and width 1024 and height 768. So this should give us the exact same, oops, wrong program, the exact same result as we had before. It's the viewport that I'm changing now. We're going to look at changing the window as well, but one thing at a time. So since we're changing the viewport, then the question is, if I say I'm going to half this, 512, and what's half 768? Again, that's 384, right? Okay, so before we do this, what's the result we expect? Okay, so we expect this image that we had in the full screen to now be half the size, and nothing basically drawn in the other 3/4 of the screen. Okay, so we don't see the line for this viewport since we cleared the entire screen. But what we have here is we're basically drawing into this area here. So everything we were drawing before with the same coordinates suddenly is a lot less. And what we had before was we were drawing into a world that had the exact same geometry as the viewport we were drawing into. So we had it, the width was 1024, the height was 768, and we're still drawing into that. So if I go and I translate one of my cubes, let's do it to a circle. That's simpler. So let's see, we can just make a new one. Draw a solid circle here. I'm going to draw a circle and I'm going to translate it all the way to the edge. 1024, 768. So that should be all the way to the top right corner of the screen. And I'm going to scale it fairly big so that we see it properly. So 3 times as big, and then we're going to draw a solid circle, and let's make it absolutely white. Where do we expect to see this circle now? Center of the screen, and what's it going to look like? Okay, so are we expecting to see a full circle at the center of the screen? 1/4 of a circle up in the corner, or 1/4 of the circle with its center in the center of the screen? What we get is this, which is what you were expecting. So we're translating it by 1024, 768, but in pixels, it's still only being translated by half of that, because we're translating within our world, and our world doesn't have any fixed anchor to the screen. It's just what we decide to kind of stretch onto it. So does this make sense that this is the image we're getting to everybody, or do you want further explanations of that? Okay, so this also shows us exactly where this viewport is, because our image is being clipped along the viewport. Even though we have control over this entire buffer, we can draw into it. We're not outside the area that Windows has given us, but still it's being clipped by the viewport. Because we've told OpenGL we only want to draw into this viewport that starts at 0, 0 and ends up here. So if we can take this exact same circle here and translate it to 0, 0 and draw it again, we have kind of the other edge of the viewport. So there's that circle. Let's draw that one first so the rest goes on top of it. So now we can do something like, say, let's go to 256, and what's the half of 384? 150, 192. So bottom left corner is in 1/4 of the screen, or 1/4 each way. Then the size of it is still 512 on the width and 384 on the height. Okay, so now we're just changing this area that we're putting the image onto on the screen. We're still not changing kind of our world. So if I go now and say, I want to, inside my display function, do something a little bit different, and say, before I call display here, I'm going to make a little function that's called void, just draw scene. Inside draw scene, I'm going to do all of these things. I'm actually going to draw the scene itself. I'm not going to set the viewport there. I'm not going to clear the screen or anything. Just draw this scene that I have. So inside display, I now want to start by clearing the entire buffer. And I'm going to set this viewport, and then I'm going to call draw scene. So this should give us the exact same result, right? Okay, so here we have it. What happens if I change the viewport now? 0, 0, this. So I'm setting this viewport, then drawing the scene, then I'm setting a different viewport, and then I'm drawing the scene again. So now we get the entire scene drawn first here into this viewport and then here. But the thing is, we're still sending in the exact same coordinates. And we're not only sending in the exact same coordinates, we're using the exact same translations and the exact same scales. So we're drawing the exact same scene, in the exact same place in our kind of imagined world, the world that we're drawing into. But each time we draw it, we're just, let's say, projecting it onto a different place on our screen, kind of copy pasting it onto different places of our screen. But we're still drawing the entire thing again. So we can do it like this, and we can then, if we want to, do the whole thing again and say, 0. I think this will give us kind of 4 versions of the same thing. Okay, so we're drawing the same image now 4 times into 4 different squares of the screen here. Now the question is, if we want one of those squares to kind of look at it in a different way, to be more zoomed in, now what do we need to do? So we're changing the viewport already. We're putting this in different places, but we're always drawing the same image. Another thing I could do, I could skip one of these, and I could say, okay, I'm gonna take the bottom left one, and I'm going to stick that back to 1024, 768. No, I'm only going to change the width. And sorry, yeah, this is the way we're going to do it. What do we expect now? Can you see the numbers that I changed? So we have 3 viewports now. One left side of the screen, but on the center, starting there and going up. So that'll be the top left quarter. The other one is the bottom left quarter. And the third one starts at the bottom left corner. No, sorry, the first one is the top left, the second one is the top right. And we have the bottom left one, except it's double the width. So what do we expect that viewport to look like? So probably going to look stretched. Okay. So same image again, except now everything is, it's not circles and squares still, it's all stretched on one side. And that's again, we're still drawing the same image into the window. It's the same image there. We're just smearing it onto a different shaped part of the kind of pixels in the actual window on the actual screen. Okay, so let's save this one later. So let's make the quarters again. This ought to get us back to here. Okay. So yeah, so now we're working with the viewport. We're always drawing the same image, but we're putting it on different, or stretching it over different pixel areas on our screen. So the question again, how do we now draw the scene from a different point of view, draw a different part of the scene? Regardless of where we're putting it on the screen, now we can put everything where we want on the screen. We want to be able to kind of look at it differently. And that's where the window comes in. So we have the viewport, and we're kind of playing around with that now. The window is kind of the square in the actual world that we're kind of projecting our world onto. So we can draw anywhere in this world. And you can already see that in this image, we're drawing some stuff outside this square that we've decided that we're drawing into. And then it simply gets clipped away. We are actually sending vertices into OpenGL that finish this circle here, right? Those vertices are being sent into OpenGL. What just happens in there is that parts of the pixels that should be rendered end up outside the screen, so they're clipped. And we can do more of that. If we want to, one of these squares to only look at this part of the scene, then we need to set the window and say the window that we're interested in looking at is a smaller part here. And so we're going to go up here to this very simple projection matrix here that we're setting up. And I'm just going to, again, make a little function here. Call it private void set window. And we kind of want to be able to set window up as float right, float left, slope bottom, slope top. Oh, let's have it left right rather than right left. So sorry, I'm gonna this code from the here. Just to make sure we have it right. So this code we move. Okay, so let's look at this a little bit. So we're using the get width earlier. Now we're going to just set in the width that we're setting up there. And then we need these, and those are the main reason I'm copying this from here, so I don't do it incorrectly and end up. Okay. So we'll understand soon enough what all of these mean. Minus signs have become some kind of hashes instead. All right, so instead of get width here, we do right minus left. And instead of get height here, we do top minus bottom. Okay, so this is a simple parallel projection matrix, and we'll learn more about those later, but the idea is that we're basically setting up the perimeter of what we're drawing into. I'm sorry if I don't want to go into the details of the projection just now, but the idea here is not right now what's in it, and I know this sounds like I'm pushing things ahead, but mainly how we're going to use it. So right now we're just going to look at how we use this setting of a window. So in this case, we can just start in draw scene and go and call this set window. Say the window we had before was 0, 0, 1024, 768. So this should give us the exact same results. Not so much. This. Okay, 1, 1 here. Right minus left. All right, minus right plus left divided by yeah. Ah, yes, of course. Yeah, I'm calling this like it were the get viewport or set viewport, GL viewport. 768. Thank you very much. Should be 1024. Okay, so it's left, right, bottom, top, not left bottom width height. My bad. Okay, so now we have the same result. So now what we want to be able to do, I'll just go through, okay, clear, viewport, window, and then draw scene. Go here and set window, at least through what we're doing here. So despite what the numbers are that we send in here, the function makes a new matrix. It's basically 16 floating point numbers, which is a 4x4 matrix. It makes it into a buffer, then it calls GL uniform, like we've been calling GL uniform to send in the color, to change things in the shader. So if we go, no, not here, here into assets and look at the vertex shader. Okay, so we have this A position. We looked at it yesterday, how we set that. We've been setting the values for U color using GL uniform matrix and color lock. And what we're doing now is we're setting the projection matrix. So it's simply a variable inside our shader program that's called U underscore projection matrix. And we're sending values into that. And then we use that here in a specific way, and we'll look at that later. But the idea here is we're setting values into this matrix, and then we're telling OpenGL, this matrix here, this actual value, these actual values are supposed to be put into the variable that has this ID in the shader. All right. So what we now want to be able to do is to say, what if I set the window to something else? If I take this one here and say this window is now going to be similar to what we did earlier, with the left bottom in half the screen, was that 256? And then 768. And the bottom will be in, what was the number? 180. Oh wait, 384. So it was 196, right? 192. And what would 384 plus 192 be then? 576, I think. So what do we expect now? We can also just, don't have to take the rest out. What do we expect to happen in the top right viewport now? So we have the other three viewports, and we're still drawing the same image in there. What do we expect the image to look like in the top right viewport? So we expect it to be zoomed in. So earlier, when we made the window smaller, when we were calling viewport, we made the image smaller. We took the whole image and we just made the whole thing smaller. Now we expect the image to be larger, but also that we only see part of it. So what happens here is something like this. So this viewport here is just looking at the center here. If I take some other viewport, like the bottom left one, and let's take the same numbers as here, except let's start them at 0, 0. So it's the same amount of zoom, but we're looking at a different spot. No, sorry, I again took the wrong ones here. So this would be something like, yeah, okay. So set window 512 and 384. So this one is looking kind of at the bottom quarter here. And then you can just play around with this. You can do whatever you want. If we want this stretched again, you take this viewport here and that here. So, okay, so it's stretching that part over. Okay, I didn't remove the other one. So we're drawing here. Since I forgot to remove the viewport, you can see that we're drawing one viewport and then we're drawing the other one on top. So I was going to take this out as well. So this is what we're drawing here. We're drawing the bottom right, the bottom left quarter of the image, but then we're stretching that over the size of 2 viewports. So if we feel that's not what we're going for, but we want it not to be skewed, how can we change the window in order for this not to be skewed? Or what does the relation between the window and the viewport have to be if we don't want it to be skewed? Sorry? Well, I could. Well, right now the width of the viewport is doubled. If I want to draw it into this viewport, this is the area on the screen that I want to draw into. But I want to draw some part of this image, but I don't want it to be skewed in this way. How can I change the window in order for it to do that? Does it make sense what I'm asking the program to do? Like I want to draw into here. Yeah, so the ratio of the window and the viewport, if that's the same, then we're probably going to get an unskewed image. So let's take what we have here in the, okay, no, let's just leave it at that. So this is the viewport I want to draw into. I'm going from 0 to 512 and from 0 to 384. If I simply go to 1024, then I'll probably get it unskewed, but now I'm drawing the entire bottom rather than just the bottom quarter. So you can then play around with that. So we have 3 viewports again, one that's on this entire part of the screen, drawing the bottom of this, one that's drawing the entire image, and one that's just drawing the center. Just play around with these numbers. You can copy what I did now in this video, or you can go ahead and do it yourselves, but it's nice to kind of play around with this just to get a feel for, it's not complex math really, but just to get a feel for what happens when you change the window you're drawing into in our big imagined anything goes world, and what happens when we change the physical position of the window that we're drawing onto on the screen. We can get the same effect sometimes by changing either one, just to kind of get a feel for which is which and what they do. Because once we go into 3 dimensions, then the window isn't as simple as a rectangular box. The window that we project onto is kind of something that we have hovering anywhere in 3-dimensional space with a camera hanging onto it. And then we take 3D space and project it onto that square. And that's what the projection matrix does in the end. But it's nice at this point to kind of get a feel for these 2 things. One, the continuous world that we're drawing into with whatever window we put it in. And we can also see that, we could make this window any size, and then we could scale the things any size we want. So right now the scales are in hundreds here in draw scene. But if I want, I could take all the numbers. I could take the window and say it goes from 0 to 1.024, and it could make all the 300s become 0.3 instead. I can take the scale down and say, I'm going to change the entire thing so it's not in centimeters anymore. It's going to be in meters now. But if I change the window size to be tiny and I change the scales to be tiny, in the end, I'll get the exact same outcome. The only thing that has any relation with the physical pixels on the screen is the viewport. Is this making sense? So play around with this. Yes? Yeah, we can look at what that looks like. So if we take, for instance, the top right one here. No, the top left one was the one that was still kind of whole. Okay. So how would the window need to look if I want to zoom out? That's the question. What numbers, how much do I want to zoom out, for instance? Let's say we double the width and we double the height. Okay, so we're going to zoom out so that what was earlier the entire screen will be the size of 1/4 of the screen. But which direction do we want to zoom out? Do we want to zoom out so the center of the screen is still the center? Or so that the bottom left corner is still the bottom left corner? Do you get the difference? Okay, so tell me what numbers to put in here to zoom out double. Left is now 0 and right is 1024. How do I zoom that out double? Okay, so the window we're drawing into, that is, we're still drawing the same image, and that's, we can just look at this here. We're drawing these shapes, but what we want to happen is that the window that we're interested in projecting from this image is not here anymore, but actually it's a much bigger part here around. So I can say, if I want to make the window bigger, we can go to 2048 here, yeah, and we can go to 15. What's this number again? 1536. Does that make sense? Yeah. What do we expect to see now in that top left corner? I've made the window that I'm projecting onto the viewport twice as big. But where is the zoom going to happen from? From the bottom left corner. So the bottom left corner will be unchanged, but we expect the rest to kind of become a smaller part of the viewport. Like so. We can even, just to make this a little bit clearer, we can say, let's skip the rest of these viewports here and make this viewport just the original full viewport. Say we're not interested in the viewport anymore. So this will just be the full screen, so we see this better. Did I change the wrong one? So here. That's the one we're interested in. Okay, so now it looks like this. So this circle that was earlier just a quarter here, it's now being drawn entirely, and it's in the center of the screen. So this circle is now full here. Simply because now, earlier we had this window that we said, and we said, this is the only thing we're interested in projecting onto the screen. That's what we can see through this window that goes from 0 to 2024. Now we're saying we have a window that goes from 0 to 2048, and that's what we're interested in seeing. But that's in our world coordinates, that's in our window coordinates, and not in our pixel coordinates. In our viewport coordinates, this is still 512, and this is still 1024. Okay, so if I wanted the zoom to happen from the center, what would I have to change? So this is a zoom out, but it happens from the bottom left corner. If I'm starting here, 1024 and 768. So this is my original image. If I want to zoom out so that this is the center, like I'm zooming directly out with the camera without changing the position of the camera, how would the numbers need to look? Okay, so this number would have to be negative. So we're looking at left and right. So before we just took left and added 1024 to that. Now we need to take, no, we took right, sorry. Now we need to take left and subtract half of that. And we need to take right and add half of that, which is 512, which makes this 1536 again. Okay, so if we just change that, okay, we're zooming out only in this direction. If we want to finish the zoom, we're going to have to go half of this, which is minus 384, and then we have to add 384 here. Gives us 1140.52. So now we zoomed out from the center. So now both of these circles are now fully seen. So we've taken our window and we've extended it outside the entire thing that we're drawing, so we can see everything we're drawing. What would then be cool, and you should actually experiment with doing, to actually see this happening nicely, is to assign variables to this and then have them change over time so that you can see the zoom happen like, and you just do the same as when you assign variables to a position of something. You start with a position at some point. Then every frame you add something, and then you simply assign that variable to a position of something, and it moves around. If we do the same thing now, except we add, or we assign that change to these variables, and then you can just put like little math examples here and say, okay, the center is always going to be this, but then I'm going to subtract and add this variable to it in specific ratios. You can get this zoom to happen. And if you have it changed not by adding a little something, but always taking, for instance, a sine function or a cosine function and multiplying that up, you can get a kind of constant zoom out and zoom in. That will be a nice effect. So play around with these things and try to see what you can have happen. I'm not going to spend more time on this now, since we've seen the effect, but it's much cooler to actually see it kind of moving around in motion. Might do that in a lab class later on, but for now, let's take a short break and then do fun vector math after for the second half of the lecture.